Assalamu alaikum dear students. We are going to start the physical properties of liquids. Today lecture is 24, physical properties of liquids, chapter 5 and grade 11. Physical properties of liquids. So when we are talking about physical properties of liquids, there are three: additive properties, constitutive properties, colligative properties. So in a liquid, the molecules are very close with each other as compared by the gases. As a result, their independent motion is greatly hindered and flow of liquid and rate of diffusion of much less than that of the gases. The existence of power forces of cohesive forces are powerful, strong in water. So that's why water is a liquid. This is the responsibility of the water to become a liquid because of cohesive forces are very strong. So there are three properties. Number one is additive. Number two, constitutive. Number three, colligative. So these are the three properties. Now when we are talking about additive properties, such properties depend upon the number of kind of atoms in a molecules, not in their numbers. Optical activity. What kind of atoms are present in molecule? Such properties depend upon number of kind of atoms present in a molecule, just like we have a molecular mass. Molecular mass. Just like water, molecular mass is 18 grams per mole. Just like sulfur dioxide gas, 64 grams per mole. It depends upon the kinds of atoms present in a molecule. This property is called additive properties. Such properties depend upon number and kind of atoms present in the molecule. That's called molecular mass, molecular weight. Constitutive properties. Such properties depend upon arrangement of atoms in molecules and not in their number, how the atoms are going to be arranged. So this you will do in the grade 12, isomerism, optical isomerism. So this is optical activity. How the atoms are arranged, not number. Number three, colligative property. Such properties depend on the number of ions and molecules present but do not depend upon the structure of molecules. Osmotic pressure and molar volume. You done in the chapter number 1. Molar volume also in the gases. Molar volume of all gases, irrespective of their molecular masses and nature of the gas is same. 1 mole of every gas contains 22.414 decimeter cube. Either hydrogen gas, helium gas, sulfur dioxide gas, ammonia gas, whatever it may be. So this is called colligative properties. Students, after this we have to start another topic. Vapor pressure. Vapor pressure and boiling point. Now let me clear one thing, that when the liquid is at room temperature, when it is going to be changed into gaseous state, this is called vaporization. means vaporization takes place at all temperatures. It is continuous process. But when the liquid is going to be heated at its boiling point, then this is called boiling. So there is a difference between the evaporation and boiling. Spontaneous change of the liquid molecule into gaseous state at all temperatures. This is called vaporization. But when the liquid molecule change into gaseous state, when you are going to heat, giving extra energy at its boiling point, when changes into vapor, this is called boiling. So dear students, vapor pressure, the pressure is exerted. Pressure, this is when the system is closed. We have a closed container and there is a liquid. So slowly and gradually liquid starts to vaporize. So when liquid starts to vaporize, it changes into vapors. So these vapors strike the wall of container and with each other. There is no escape to out. Concentration of vapors will be increased and the condensation taking place. So dear students, when the rate of vaporization and when rate of condensation equal, this is equilibrium. So this is the vaporization, vapors, and this is the condensation. So when the liquid changes into vapors and when the vapors change into again liquid, so then we can say that there is a condensation. So liquid, this is a liquid, changes into vapors. The temperature at which the liquid changes into vapors, this is called vaporization. System is closed. So when the vapors again change into liquid, this process is called condensation process. Vapors change into liquid, this process is called condensation process. So when the equilibrium is established between the vaporization and condensation, the pressure is created by the vapors at the surface of the liquid is called vapor pressure. The pressure is created by the vapors at the surface of the liquid at a particular temperature is called vapor pressure of that liquid. Dear students, vapor pressure increases by increasing temperature, and also vapor pressure is different by different liquids. Water has a different vapor pressure. Strong hydrogen bonding, it has a less vapor pressure. Ether has a high vapor pressure because there is no hydrogen bonding, so it gives the high vapor pressure. And if we are going to increase the temperature, the vapor pressure of a liquid is going to be also increases. So again I am telling you, done in grade 9, that at equilibrium, when the vapors change into liquid change into vapors and vapors change into liquid, there is an equilibrium. So at this equilibrium state, the pressure is exerted by the vapors of the liquid at the surface is called vapor pressure. Now, students, there is a boiling point. Boiling point is when the vapor pressure of the liquid becomes equal to atmospheric pressure. External pressure is called boiling point of that liquid. When the vapor pressure of the liquids become equal to atmospheric pressure is called boiling point of the liquid. This boiling point varies change from place to place. We are standing at sea level where atmospheric pressure is a 760 torr or 1 atmosphere pressure. The boiling point of water is 100. But when we are going to climb, when we are going to go up hills, high altitude, the atmosphere pressure will decrease. The boiling point of the liquid is going to be also decreased. So it depends. Boiling point of the liquids depend upon atmospheric pressure. Written in your book, boiling point of water at 760 millimeters of mercury is 100 degrees centigrade at sea level. But the boiling point of water at 25 degrees Celsius means room temperature 23.7 millimeters of mercury. So when you maintain 23.7 millimeter mercury, the water boils at room temperature 25 degrees centigrade. But at sea level, 760 millimeter mercury, the water boils 100 degrees centigrade. So that's why the boiling point changes, varies place to place. When we are going to go up hills, high altitude, that's why boiling point is going to be changed. When we increase the pressure, the boiling point is going to be increased. Suppose we are going in the tunnel down the earth, so pressure is going to be increased. Pressure is going to be increased and the boiling point of water is going to be increased. There's another thing. So when we use a pressure cooker, when we are going to use a pressure cooker, so you know the pressure cooker is closed container. Pressure cooker is a closed container. Only safety valve is there to maintain the atmospheric pressure. Please, you have to know that the pressure cooker give the about 2 atmosphere pressure it works, because depending upon material we use. Or if good material, then we have to give the 2.5 atmosphere pressure. So 2 to 2.5 atmosphere pressure is going to be given to the pressure cooker. Otherwise, from the safety valve, this pressure is going to be released inside the pressure cooker. So it will give 2 atmosphere pressure or 2.5 atmosphere pressure. So this is a closed container. So when we use closed container at any place, irrespective of the high altitude or low altitude, so on the closed container there is a low effect of atmosphere pressure. There is a low effect of atmosphere pressure on the closed container. That's why equal time is going to be taken by the cooker to cook the meat. That's why when you increase the temperature and this valve is only here and it is closed one, the pressure inside the cooker is going to be increased. The vapor pressure of the liquid water is going to be increased inside the liquid, inside the cooker. So when it reaches to 2 atmosphere pressure, the boiling point of water is going to be about 120 degrees centigrade. So boiling point of water is going to be increased up to 120 degrees centigrade. So that's why when the boiling point is going to be increased, water becomes more energetic. It has a more energy. That's why the hard meat or other pulses are going to be cooked very easily in the pressure cooker. Or you are going to maintain about 2.66 atmosphere, means 2026 millimeters of mercury. If it is good quality of cooker, then it will give 130 degrees Celsius. So 136 Celsius is a very high temperature for the water. Boiling normal is a 100 degrees centigrade, but you are artificially giving the pressure inside the cooker. So it is a very high pressure. So boiling point is going to be increased, so that's why the rate of cooking is going to be decreased. There is the one thing, decrease in pressure. What would the effect? Decrease in pressure. Dear students, you heard about the separation of different components, small components from the mixture. So different types of distillations we use. One is the normal distillation, where the water contains some salts, just like seawater, pond water, dust particles, other also river water, which is dust particle contained. So how we are going to separate by using normal distillation? Because the boiling point of salts much higher than that of the water. That's why when we heat the water is going to be boiled at 100 degrees centigrade, changes into vapors, but salts do not, they remain in the bottom. So when we condense back, the vapors change into water, this is free from the salts. This is a normal distillation. There is also destructive distillation. There is a fractional distillation. Now here is distillation at reduced pressure. Distillation at reduced pressure we call vacuum distillation. This is a very useful method to separate the liquid from its impurities. How? You know glycerol, high boiling liquid. It has a normal boiling point about 290 degrees Celsius. 290 degrees Celsius a boiling point of glycerine. So if it contaminated, if it contains impurities, so we are unable to use normal distillation to separate from its impurities. The reason is because when you are going to heat it, the vapor pressure is going to be increased. So when the boiling point reaches at 760 millimeters mercury, before reaching this, so a boiling point, the glycerine is going to be decomposed. Glycerine is going to be decomposed instead of the separation from the impurities. That's why we are unable to separate from the impurities glycerine at its normal pressure, its normal boiling point. So that's why the scientists make method to separate from the impurities. So we use reduced pressure. So when you are going to decrease the pressure, the boiling point of glycerine is going to be also decreases. So dear students, when we are going to decrease the pressure about 50 millimeters of mercury, then the boiling point of glycerine is about 120 degrees Celsius. At 760 millimeters of mercury, the boiling point of glycerine was 290 degrees Celsius. So we are unable to separate impurities from the glycerine at normal pressure, because before reaching this boiling point at normal pressure, it is going to be decomposed. So we decrease the pressure up to 50 millimeters of mercury. The boiling point of glycerine is going to be decreased, so it becomes 120 degrees centigrade. So at reduced pressure and boiling point is also going to be decreases, so we can purify glycerine from its impurities. So there are two advantages for this one. One advantage is going to be less fuel is going to be consumed. because actual boiling point is a 290 degrees centigrade, so we use more fuel. Here we use 120 degrees centigrade, so less fuel is going to be used. Then time, consumption of time, because the pressure normally is 760 millimeters of mercury, so reaching to this pressure it will take time. But here the pressure is only 50 millimeters of mercury, so it will less take time for the purification. So that's why we save the time and also we save the fuel by using this apparatus to decrease the pressure of the inside the apparatus, so we can separate the glycerin from its impurities. The same thing I told you, evaporation. Dear students, evaporation is a continuous process, I told you, and it's cooling process. Evaporation is a cooling process and a continuous process. When the open container is there and there is a liquid, suppose there is alcohol, so slowly and gradually it is going to be vaporized, changed into vapors. And how it gives the cooling process? When the high kinetic energy molecule of liquid present on the surface, they escape, high kinetic energy molecule of the liquid present at the surface change into vapors. Then low kinetic energy molecule taking place. So due to the taking place of low kinetic energy molecule at surface, suddenly temperature drops. That's why evaporation is a cooling process. Just like you are going to put perfume on your palm or acetone on your palm. So when perfume contains alcohol or acetone or their polish remover, so when it's going to be evaporated, you feel cool. That's why because of the evaporation, the high kinetic energy molecule escape and low kinetic molecule, they are taking place. That's why suddenly temperatures drop. Evaporation, effect of evaporation now. What are the factors? Surface area, yes. If we have a water in the jug or big container, so it's not going to be evaporated quickly. But when you are going to scatter water in the room, on the floor, so it will be evaporated quickly because surface area of water is going to be increased when you are going to be put onto the floor. But if it's present in a small tub or small bucket or small container or even in the jug, it is not going to be evaporated because surface area is going to be less. Intermolecular forces, already I told you, water has a strong hydrogen bonding, so its vapor pressure is very less and vaporization time is also very less because hydrogen bonding are strong. So what is not going to be evaporated quickly, but acetone, alcohol, they are going to be evaporated very easily because intermolecular forces are weak. Temperature, definitely increase the temperature, increase the vapor pressure of the liquid. That's why it gives more vaporization. Less time will be required to vaporize for the liquids. So vapor pressure, already I told you, affecting our vapor pressure is same, and intermolecular forces, strong intermolecular forces, less vapor pressure, and weak intermolecular forces, more vapor pressure. If you are going to increase the temperature, the vapor pressure is going to be high, and the low temperature, the vapor pressure are going to be low. So you have to read this one. This is the same as, and boiling point I told you. You have a figure here, effect of temperature on the vapor pressure. Diethyl ether, on the horizontal line there is 760 millimeter of mercury or 101,325 Pascal atmospheric pressure. So vapor pressure of ether is already very high because it's a low boiling liquid. Intermolecular forces are very weak. That's why the normal vapor pressure at 25 degrees centigrade is about 200, less than 200 vapor pressure at very high. But when you heat it, So it is going to be boil at 34.6 degrees Celsius. Ethanol has a strong hydrogen bonding as compared to ether, so its normal vapor pressure is very low, about 20 or 30 or 40 maybe. So its boiling point is 78.3 due to strong hydrogen bonding. Water boils at high temperature 100 degrees centigrade and vapor pressure is very low indeed at normal temperature, strong hydrogen bonding. Ethylene glycol, which is used in the car radiator, it contains 2 hydroxyl groups, 2 carbon atoms, 4 hydrogen atoms with the high melting point, boiling point. So it is going to be boiled at very high temperature because strong hydrogen bonding and strong intermolecular forces are there. So different liquids boil at different temperatures because of different intermolecular forces. Viscosity. Viscosity of liquids. Rate of flow of liquid. Rate of flow of liquid is called viscosity. The liquid resistance to flow is called viscosity. Just like you have a water, and if you are going to pour, it will flow with a high speed. And but if you have honey, if you have a glass rod, if you pour, it will take time. It means that honey is more viscous than water. The law of viscosity of more slowly the liquid flow, high viscous liquid, how easily molecules slide on one and other. To understand viscosity, we are going to see how the liquids are going to flow. We have a tube. This tube has a liquid and it contains series of the circular layers. There are layers present in the liquid. The resistance flow is due to the internal friction between the layers of molecules. Internal friction between the layers of molecules or liquids. Now the layer adjacent, neighboring to the wall have a low viscosity. So dear students, when you are going to flow the water or any liquid, it starts flow from the center, not from the sides. The water will flow from the center. Center molecules first flow. The layer adjacent to wall have the low viscosity. That's why. Each layer exerts drag on one and other, thus causes resistance to flow. So, depends upon hydrogen bonding, depends upon intermolecular forces. I told you arrangement of molecules, size of the molecules, and also shapes of the molecules. Irregular shaped molecules have high viscous liquid. Regular molecules shape have the low viscosity. System international unit of the viscosity is Pascal second, kilogram per meter per second, newtons per meter square. The SI unit of viscosity is poise. 1 poise is equal 100 grams per meter per second or gram per centimeter per second. Same effect factors. Viscosity depends upon I told you molecular shape or size, intermolecular forces and temperature. Strong hydrogen bonding, high viscous liquids, high molecular mass, more viscous, just like crude oil. Crude oil is a high viscous liquid because it contains many carbon atoms. They are going to be connected with the catenation carbon atoms. Graphene is a high viscous liquid. Honey is a high viscous liquid. Water is a low viscous liquid as compared to these liquids. So depending upon these things, stronger the intermolecular forces, higher the viscosity of the liquids. So as we increase the temperature, the viscosity is going to be decreased because hydrogen bonding is going to be decreased. Surface tension. Surface tension also related with the hydrogen bonding and also the viscosity. The surface tension is the property of the liquid, of the surface of the liquid act as if there is a membrane straight across. So we can understand that level of the liquids acts as surface tension on the surface. You know, on the surface, this is the container, beaker, and then water. So students, if you see the interior molecules of water, between interior, this is the interior molecule. It attacks this water molecules, it attacks this water molecule, it attacks this water molecule, it attacks this water molecule. So all sides same forces are there. So there is no tension. These water molecules can move freely because all forces they are cancelled out. But this molecule has a force of attraction and here, but there is no force of attraction upward. So that's why the surface molecules they go down with the force of attraction of downward molecules to create surface tension. So this is the cause of surface tension. All molecules below the surface of liquids are surrounded by the same type of other molecules, they are surrounding them and they have equal forces. Thus the force accepted by the submolecules are balanced in all directions. Now whereas the molecules of liquid surface has a molecules beside and beneath the above force. There is no force on the above. That's why this results in the unbalanced force pulling the surface molecule inward. The molecule will move inward. A straight membrane is created on the surface of the liquid. The definition of surface tension is also here. The force in dynes acting at a right angle on a unit length of the surface of liquid is called surface tension. The force in dynes acting at a right angle on a unit length of surface of liquid is called surface tension. So it must be downward when the forces are unbalanced. This means what be done to pull the surface. Therefore, increase in surface area of the liquid requires input energy. So other definition of surface tension is also you have to write all. The amount of energy required to expand the surface of liquid by unit area is also called surface tension. So molecules of the surface molecule, they are unstable and that's why they are starting to evaporate. They have high kinetic energy, unstable. Dear students, there is one thing. When you are going to pour a water, the droplet has a shape spherical. It has a shape of spherical. The molecule at the surface of the liquid are less stable than those of the inside it. So liquid is stable when the fewest molecules are at its surface. This occurs when the liquid has a maximum surface area. The liquid has a maximum surface area. Spheres have less area per unit volume than other. Spheres have less area per unit volume than any other. Therefore, small drops of liquid tends to be spherical. Now again, factors are same. Intermolecular forces are strong, the surface tension is very high, viscosity is high, boiling point is very high. If a temperature is very high, surface tension is low, viscosity low boiling liquid. If temperature is a less, surface tension is a high, viscosity is high, and also nature, intermolecular forces, again same this units, surface tension units are joules per square meter, joules per square meter or newtons per meter, newtons per meter. Dear students, water give analogous behavior. Water give a strange behavior of water. This answer I am telling you, this is due to the strong hydrogen bonding. Due to strong hydrogen bonding, water give analogous properties, strange behavior. How? Water always freeze from top to bottom, not bottom to top. Other liquids, they freeze from bottom to top. When you put the water in the deep freezer in the bowl, so you can see that it starts freezing from top, or in the very cold countries just like Siberia and America, other very low temperature in the winter, so lakes are going to be, the water present on the surface is going to be frozen, but inside the water is going to be same at liquid state, and all the aquatic life they are spending 3-4 months under this blanket. So this behavior is due to the strong hydrogen bonding. Strong hydrogen bonding. And there is another thing. In the water liquid, the water is in liquid state. These water molecules are irregularized. They are attracted in irregular manner. So when you are decreasing the temperature, so these water molecules are going to be regularized, and please mind it, the density of water is going to be increased. 25 degrees centigrade, now 20, 10, like this one. So at 3.98 degrees centigrade or 4 degrees centigrade, the water has a maximum density about 1 grams per centimeter cube. Water has a maximum density at about 4 degrees Celsius. These molecules are going to be regularized. When you are increasing more or decreasing more temperature, so water molecules are going to be more regularized, and the density is going to be decreased, and volume is going to be increased. The volume is going to be increased and density is going to be decreased. So when it is frozen, so density is so decreased that this ice floats on water. Ice floats on water, and volume is going to be about 9% increase. 9% the volume of the water is going to be increased. You can make experiment. Take a small bottle small, put the water on the top. Then you have to close it and you have to put in the deep freezer. After 1 hour, 2 hours, when the water is going frozen, then you can see the cracks. The plastic bottle have some cracks because of volume of the this ice is going to be increased 9% more, because you close the bottle, there is no space to out, so that's why it is going to be broken. So this is the strange behavior of water, and also heat capacity of water is very high. That's why on the very cold mountains, just like Siachen Glacier, these armies going to make their homes igloo, we call them. Blocks of ice they have, because of outside temperature is not going to be passed through the blocks. That's why inside the igloo the temperature is somehow higher than that of the outside temperature. So due to this reason, the ice which is present on the surface, outside temperature is not going to be passed. The whole ocean, the whole water is not going to be frozen down, only the layer is going to be formed. So that's why inside all fishes are going to be surviving. This is the analogous properties of water. Hydrogen bonding, already I told you. High surface tension due to the very strong hydrogen bonding. High heat capacity. Also, 1 gram, you have the definition, the quantity of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius or 1 Kelvin. The specific heat of water is 4.180 joules per gram per degree Celsius. This is very simple. You have an iron, metal, sheet of iron, metal or metal, and we have a water. When you are going to put in the room and calculate its temperature by using thermometer both, take the temperature of iron or metal or take the temperature of water by using different 2 thermometers. Now put in the outside in the sunshine at 1 o'clock, 12 o'clock. So temperature is outside is higher. You can see that metal is going to be formed very quickly. The temperature of the iron or metal is going to be increased very quickly, but the temperature of water is going to be increased very slowly due to the high specific heat. After 1 hour, when the maximum temperature attained, then bring back in the room, you can see that putting the thermometer, the temperature of water is going to be decreased slowly and gradually. But the temperature of the metal is going to be decreased very rapidly due to this very high specific heat of water. Heat of vaporization. Heat of vaporization of water is going to be high because of strong hydrogen bonding. The amount of heat is required to convert 1 mole of water liquid into 1 mole of water gas is called heat of vaporization or standard heat of vaporization. So if you see that if you are sitting near the pond, near the river, so temperature is a moderate temperature. But if you are sitting in a desert, so temperature is very high. So because of water vapors are going to be modifying the temperature of the earth. That's why on the globe 75% water is there and they are maintaining the temperature of the earth. High boiling point, I told you boiling point of water is 100 degrees centigrade at 1 atmosphere pressure, and the boiling point of the benzene is 50 degrees Celsius and 45 degrees centigrade at low altitude. So there because of the weak force of attraction. So dear students, we are going to close here. Only one topic is going to be here. So inshallah next time we will complete this one. So and then we will start new chapter. Thank you very much.